Hi everyone, welcome to another video lesson for Unit 8. So let's go ahead and get started. On the previous lesson, you learned or you reviewed how to distribute or how to multiply polynomials. So I'm just going to give you one example to help you or to prime your brain so that you're able to understand what we're doing today. So what we're doing today is we're factoring using GCF only, okay? And GCF, don't forget, stands for greatest common factor. And when you're factoring, you're actually dividing. So in this example, we're going to do the opposite of division, which is multiplication by using the distributive property. So when I multiply or when I distribute negative x squared times negative 2x squared, negative times negative becomes positive, and then positive 2, then x to the second times x to the second is x to the fourth based on the properties of exponents. And then negative x squared times positive 5x, negative times positive is negative 5x to the second times x to the first is x to the third. Negative x squared times negative 4 is positive 4x squared. So this is what the lesson from yesterday or the previous lesson was about, okay? All right, so now let's go into factoring. So when you're trying to find the greatest common factor, just think of a number you can divide by, and it's going to be the greatest common factor of, in this case, two terms. So we know that 4 goes into 8 and 4 goes into 4. So then the GCF is 4 for both of these. So then GCF is 4. So this is just asking you, what is the GCF? The GCF is 4. Example number 2, for example, in this term, we see that this has x squared, this is y, this has x, and this is y squared. So then we can factor out x, okay, because this is x squared, and also here we can factor out x. Now this is y to the first and this is y to the second, so that means we can factor out also a y. So the GCF for this problem is x times y. Example number 3. So if you look at the number 8, the number 4, and the number 12, you can see that numerically the GCF is 4. So 4 goes into 8 twice, 4 goes into 4 once, and 4 goes into 12 3 times. So then the GCF for this problem is 4. That's when it comes to the numbers. But when it comes to the variable x, this is x to the third, x to the second, x to the first. So then that means we can factor out also an x. So then the GCF for this one is 4x. All right, so for today only, we're just going to use the GCF. And then tomorrow, the next lesson, we'll do factoring, binomials, trinomials, whatever polynomial we might have, okay, or you might be given. So we're going to check. I am not going to check for the sake of time, but I'll do this with you in class. So one thing you have to look for is there another GCF? Like, for example, if I would have stopped at 4 here, but there's an x left, then, you know, I would have had to go back and check, okay, there's another GCF, and that other GCF is x, because they all have it in common. The same thing here. If I just saw the x at first, but I ignore the y, and then I would be able to see what else they have in common that I can factor out as GCF, and in this case is the y. So that's what number 1 is saying. Number 2, distribute to check. So then go back and distribute like I did here to check and see if you get the same problem that you were given, okay? All right, so let's start with this one here. Example number 1. 4 does not go into 11, right? But this is x to the third and this is x to the fifth. So then GCF is x to the third. We can factor out a GCF of x to the third. So then what I'm going to do is I'm going to write down x to the third, open parentheses, and this becomes just 4. And then this becomes minus 11x squared because we divided by x to the third. So this will be the answer to the first example. The second example, we can see that we have 20, 24, and 18. You might think, well, I think 4 goes into all 3 of them, but 4 does not go into 18. So then when it comes to the numbers, the only factor that 20, 24, and 18 have in common is the GCF will be 2. GCF is 2, right? So then I'm gonna write that down. Then I notice that this is x to the first, x to the second, x to the third. So then I can factor out a GCF of 2x from each one of those 3 terms. So then here comes the GCF. Then I'm going to open parentheses. And 20x cubed divided by 2x is 10x squared. Negative 24x squared divided by 2x is negative 12x. And negative 18x divided by 2x is negative 9. And if I distribute back, you know, these 2x inside of this parentheses, and I should be able to get this back. So this is the answer to example number 2. All right, let's go on to the next example. For this example, notice that we have a negative lead, so always factor out lead negative. So I have negative lead here, so I'm going to factor it out from every single one of them. So I see that 8 goes into, let's see, 8 does not go into 28. It goes into 16, but it's got to be able to go into all of them. So then 4 goes into 8, 4 goes into 28, and 4 goes into 16. So then negative 4 will be GCF of all 3 of them. And then when it comes to the variables, this is x to the 6th, x to the 4th, x to the 5th. So this is the smallest of the powers. So that means I can factor out x to the 4th. And they also have in common y, 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 and this is y to the 3rd. So I can also factor out y to the 1st power. So x to the 4th and y to the 1st. So then this is the GCF. So negative 4x to the 4th times y times, now this becomes positive 2x to the 2nd, and there's no y with this one. Then minus 4 goes into 20 into 28 7 times. So 7, and it becomes plus, right? So plus 7, and then and this one becomes negative. So 4 goes into 16 4 times, and this is x to the 5th. We factor out x to the 4th, so this is 4x, and this is y to the 3rd. So this becomes y to the 2nd, okay, because we factored out a GCF of y. So then this is the answer of number 3 with the GCF of negative 4x to the 4th times y. Okay, last example. For this one, we have 15, 25, and 5, which means there's a GCF of 5 on each one of the terms. So then this is x to the 4th, x to the 4th, x to the 4th. So that means we can factor out x to the 4th, y to the 2nd, y to the 3rd, y to the 1st. So x to the 4th and also y to the 1st as a GCF. Okay, so then the GCF of 5x to the 4th power times y, and then open parentheses, this becomes 3, and there's no x left, and there's only y, so 3y. Plus from here, we have y to the 2nd left, right? So for this one, not only y to the 2nd, but also 5. So 5 times y to the 2nd power. And from this one, this is where you need to be careful. If the whole thing, if this, when you divide 5x to the 4 by 5x to the 4th times y, divided by 5x to the 4 times y, then that just gives you a 1. Okay, so I'm going to write a note here just to help you remember this, because I know you have not done this in a while. And that is, do not or don't forget, okay, don't forget 1 as a placeholder. Because if I distribute back the GCF, I should be able to get this polynomial back, okay? So I need that as a placeholder, so when I distribute it again, I get that back. So that's all for this lesson. Thank you for watching. I'll see you in the classroom. Bye-bye.